Okay, just reading this and then I'll write some stuff on paper. This is now exercise 6.7, motion and integration. So girls, if you're given, one sec. If you're given exercise 6.7, motion and integration. Now, this is what we've been doing so far. If you're given X and you want V, what do? Differentiate. And if you've got V and you want A, you differentiate. All easy, no constants involved. But if you're given A and you want V, you have to integrate. And if you've got V and you want X, you have to integrate. Just the opposite. So, downwards, differentiating, going back up that way, it's integrating. And that's all we're going to do. Remember, when you integrate, don't you get your plus C? So if you integrate A, you get V plus C. Then we've got to do the substitution to work out what C is. Put it back in and answer our question. If you start with V and you integrate, you get X plus C. So just don't forget to put your plus C, work out what your plus C is, put it back into the equation and answer the question. With differentiating, there is no plus C. All right, but differentiation can be, the most difficult bit about the differentiating is the distance travelled and making sure you know where it stopped and came back and doing those overlaps. That's probably the worst thing about that, all right? The pause. I'm not sure, I don't think I've gotten through this question. So question 4, velocity of a particle is given by 8t cubed minus 3t squared. Over here, it's a good idea, you know, that you start with displacement. If you differentiate, you get velocity. If you differentiate, you get acceleration. But if you have to integrate going back upwards, here's your equation. They told us that when t, initially it's at the origin, so when t is 0, x is 0. We've been asked to find acceleration when t is 5. So we've got the equation for velocity. To get acceleration, we differentiate. We get 24t squared minus 6t. When t is 5, we substitute 5 into the t, and we get 570 centimetres per second, because velocity is centimetres per second, and we're dividing it by seconds again. Part B, find the displacement, in other words, find x when t equals 3. We've got v, but we need x. Well, if you've got v and you want x, you integrate. So going down is to differentiate, going back up is integration. So we integrate. X is the integral of 8t cubed minus 3t squared dt. That's using proper notation. So you should go integral of that, which is 8t 4 on 4 minus 3t cubed on 3 plus c. So therefore, x is what? 2t4 minus t cubed plus c. Now I need to work out c, so I need something about t and x. It was given in the question. When t is 0, x is 0. Remember? It's up here. It was in the question. So we put that in. When t is 0, x is 0. What do you get? C is 0. Therefore, that's a nice one. X equals 2t4 to the power of 4 minus t cubed. The last part of the question, wait, we're still not finished. So, find t. So with this question, we've got the equation for x in terms of t. We want the displacement when t is 3. Displacement, there it is, when t is 3. So when t is 3, we get that x is 2 times 3 to the power of 4 minus 3 cubed. What's 3 to the power of 4? 81. 2 times 81, 162 minus 27. Anyone? 135 units, it's displacement. Meters. Centimeters. Thank you. 135, very important. Look at the question, and I should. Centimeters per second. So it's 135 centimeters. Next part of the question, when will it be at the origin again? So part C. Makes you want to. Says if the particle is initially at the origin. So the last one, when will the particle be at the origin again? When x equals 0, find t again. I know you think it's only 0, it's not. You know why? Because it's actually a cubic. Positive or negative cubic? Positive. So it's going to cut through, see, it looks like this. And I'm not sure exactly where it starts. When t is 0, look, I'm not sure where it, do you know what I mean? It'll look like this. I'm not sure exactly where. When t is 0, x was 0, it's going to go like this until I factorize it. I mean, we can. Let's just have a play around. So v equals 8t cubed minus 3t squared. Oh, you've got a double. It is 2. Thank you. Bad. Oh, it's a quartic. Which one? One of these ones. Must look like that. Some sort of W. We don't want to draw that one. Let's just go back to this. Forget the deviation and the sidetrack. Too hard. We don't want to draw quartics. Okay, when x is 0, find t. It still is a power of 4, 1. Oh, no, we'll try. So x is 2t4 minus t cubed. X is 0. 2t4 minus t cubed. Let's factorize. We've got it. T cubed, what? 2t minus 1. So therefore, t is 0 or 2t minus 1 is 0. So it's just at half. That's a very fast thing. Ooh. So girl, the origin, half a second later it's back at the origin. They're then asking you for, it must go, you know, with that graph, it must go like that straight away. Like, so at t is a half. So for example, it's a quartic, right? From our extension 2. And it's a W. You know how, so it obviously goes like this, and at half a second later it's back at the origin. I'm not sure what it does after that, but that's the beginning of the W. A quartic is a W. You don't have to know this for mathematics. I'm just tying it in with your knowledge of graphs from extension 1, your knowledge of polynomials. But that's what happens. Now, because we know, in other words, it must have, at time is a quarter or something, it must be traveling negative velocity. It's traveling, yeah, it is. It's traveling to the left of the origin initially. So if we do velocity, and if I put a quarter, that should be negative, is it? What's 8 on 64 minus 3 on 16? 8 on 64 is 1/8, which is 2/16 minus 3/16. See, negative 1/16. It's negative velocity up to here, and then positive, and then it's at the origin. That's it. We got t as a half a second. So the answer is at 0.5 seconds. What I'm trying to do is show you the motion of the particle. Don't worry about the extra bit if you don't get it. It's just for those that are interested. This before, but I didn't look at the triple root there. Thank you to Jin. So we've got a triple root at t is 0. So just a bit of revision from extension 1. At triple roots, it's an inflection. So because you've got, so it must go like this and then back up a half. So there's a single root at t is a half because that's to the power of 1. And you've got a triple root at 0, which means it's an inflection. Okay? And we knew we had negative velocity originally, so that's why we know it's that way too. All right? But don't worry. I don't think you get something like that. That's just point 7, question 9. A particle is accelerating according to this equation. A equals 3t plus 1 squared meters per second per second. Now, if you are going to not integrate this correctly or whatever you're going to do, or differentiate, whatever you're going to do, I'd be expanding it if you're going to not do it properly. Acceleration is 3t plus 1 squared. If the particle is initially at rest 2 meters to the left of 0 or O, it's actually O, origin, find its displacement after 4 seconds. Tell me what that's telling me in mathematical notation. So initially, when t equals 0, what do we know? We know something else. If it's initially at rest, v equals 0. And also, we've got two things. So if the particle is initially at rest, 2 meters to the left of 0. So when t is 0, I know something about its position. X is negative 2 meters. So if it was to the right of 0, what would you put here? Plus 2. Just a normal 2. Find x displacement when t equals 4. Good. Okay, that's what we've got. So let's write down the side. X, then v, then a. Going down is differentiating. Going up is integrating. X, v, and a. So what do you think this question involves? Integration or differentiation? All right. Do you remember how to integrate 3t plus 1 squared correctly? Yeah. All right, let's see. If you don't know how to do it correctly, what would you do? Expand it. What would you get? 9t squared plus 6t plus 1. Probably easier to do it. Do you want to expand it? No. All right. For those that do, I'm doing it over here. A is 9t squared plus 6t plus 1. Therefore, v is the integral. I'm doing it both ways because I'd hate to see you get it wrong if you didn't integrate properly. So let's do it this way too because it's good practice of the rule. Do you remember the rule? Integrate. Don't you increase the power by 1? 3t plus 1 cubed over 3 times what? Times the coefficient of t over 3 times this 3 there. Plus c, don't forget the plus c. Now, if you're going to take that on and do that, have your formula sheet there. Make sure you don't make a mistake because you lose a mark. And not only will you lose the mark when you make the mistake, the answer is not going to be the nice little number that it was meant to be. All of the algebra is going to get a lot harder and the numbers than they were ever intended to be. So this way, so what do we get? 3t plus 1 cubed over 9 plus c. This way we get what? 9t 3 on 3, which is 3t cubed, plus 6t squared on 2, which is 3t squared plus t plus c. Now, what do? Sub. We need the c. So we have to sub a t and a v at the same time. Sub. T equals 0, v equals 0, and you get 0 equals what? What do you get? Please don't make the whole numerator 0. Let me tell you how many people would do that. The t is 0. What are you left with on top? 1 cubed, which is 1 on 9 plus c. Therefore, c is negative 1/9. If you want to do it this way, when t is 0, v is 0, 0. This is not good. Have I made a mistake? This should work. This is really bad. Is it 9t cubed on 3? This is why. But for some reason we're getting c is 0. We really should be getting the same thing here. I don't know why this is not working. So, yeah, I don't know. It's really, really bad. So we'll just continue with this. But it should actually work that way. It should be able to work both ways. We should get the same answer. So we will proceed with the left. Don't know what's going on there. But it should work. Don't know why it's not working, but it should. Really don't know why. Don't At the moment, don't put it, but I'm going to have to speak to someone and see if they can, but I can't see what we've done wrong. And we should be allowed to do it this way. There is nothing wrong with doing it this way. Don't know why we're not getting the same answer. Okay. So C is -1/9. So therefore, V equals 3t plus 1 cubed over 9 minus 1/9. Okay, what's next? Find the displacement when t is 4. Well, first we need displacement. So x is going to be the integral of this dt. So girls, you've got to get the notation right. X is the integral of that with respect to t. So what do we get? I wouldn't be pulling. Yes, you can. Pull out 1/9 to the front. So it's 1/9 integral of 3t plus 1 cubed minus 1 dt. Are we good with that? I'd pull out the 1/9. Good idea. So it's 1/9 times. Be careful, but actually, I don't know. Then we've got to, well, we'll see. All right, I know it does, but. So yeah, 3t plus 1 to the power of 4 over 4 times what? 3 minus t.
Plus C.
Yeah, plus c. Normal brackets. I've just put square brackets. Which is, look, okay, so we've got that. You can, if you want, put now that that's 12 times 9, 84, or you can keep the 1/9 out the front. I don't know. What are we going to substitute now?
X equals -2.
Sub x is -2, t is 0. So we get -2 is 1/9. What, -2? That's -6 plus 1, -5 to the power of 4 over 12 minus, that's right, thank you. T is 0. What do you get? 1/12? Be careful. Minus 0 plus c. What a mess. So -2 is 1/9 times 1/12 is 1/80, 108 times tables, plus c, which is whatever that is, -2 and 1 and. So C is -2 minus 1 over 108. So it's -2 and 1/108, which is -206.17 over 108. What a horrible value.
Yeah, it works out to a nice number.
-217 over 108. Is that nice? Sorry. Oh, lovely. So therefore, x is, I'm not being mean, 3t plus 1 to the power of 4 over 12 minus t plus or minus 217 over 108. And you can't even see what I'm doing. There. Make it bigger. Oh, anyway, you just do it, girls. So that's your formula for x. I don't know if I would have pulled out the 9, actually. Yeah, I probably would have left it. But doesn't matter. So now substitute t equals 4. And you get x is 1/9 times, well, what's that? 13 to the power of 4 over 12 minus 4 minus 217 over 108. And apparently it's a lovely answer. Oh, meters.
I told you.
Lovely. 262 meters. Next time, I don't think I'd pull that 9 out. I don't know. Up to you. Yeah. Okie dokie. How are we going? You think you're all right? Main thing is to read the question and write when t is this, v is that, when t is this, x is that. All right? Really important to